All right. More power rule. So no new calculus really. It's more practice on the power rule, and the focus is really on the meaning of derivatives. But we already focused on that already. What algebra word should your brain tie to derivative? What does derivative tell you about the graph? Slope. Again, you've got to have those two words tied together in your brain. Derivative tells you slope, slope tells you derivative. So when it says find the slope of the tangent line, that's really just fancy talk for find the derivative. So, there's some algebra here first. So I'm going to do the algebra. I'm going to rewrite some of those so that I can take their derivative. So 2x to the 11th is fine, but I want to write the others as, welcome back, Claire. You're first on the spot here. I want to rewrite the others as with exponents so that I can take a derivative. I can't take a derivative of fourth roots or seventh roots. I can only take a derivative of powers. So, Claire, I think I've stalled long enough for you to think about that one. How could I rewrite the fourth root of x cubed?
12x to the 3/4.
Got it. Audrey, how about 6 over x to the 5th?
Is it x to the negative 5th?
It is. And then Elizabeth, how about 1 over the 7th root of x squared?
X to the negative 2/7.
Good. So there's our algebra step. Again, please don't stop there. That's a somewhat common mistake. Like, fight through all the algebra and be like, okay, I did the algebra, and then move on. Like, no, yes, but we need to take a derivative. So it looks like I got 4 people who can take derivatives here. Harper, Lila, Laura, and Hector. So Harper, start us off. The derivative of 2x to the 11th?
22x to the 10th.
22x to the 10th. Yes. Lila, how about the derivative of she's not here. Okay, so do we move Laura up? Or we'll just put Braden on the spot. He can handle it. Braden, the derivative of 12x to the 3/4?
9x to the negative 1.
9x to the negative 1/4. Yep, bring the power down and reduce it by 1.
And then it's negative 30x to the negative 6th.
Very nice. And Hector, that last one?
Positive 4x, negative 9 over 7.
Yes. Decrease the power by, or bring the power down front. Hector included the sign change there, negative 14 times negative 2/7 is positive 4. Decrease the exponent by 1. There we go. Again, there was nothing new in that one. It's just the emphasis on making sure, just more practice. Number 2, consider the function given by that thing. What is the slope of the line tangent to the graph when x is 1/3? So how is number 3 different, or number 2 different than number 1? Okay, if you want to go the long way, we would use the alternate form. That's true. And that's related to what I was hoping someone would notice. And I guess you did notice it. Like, we got a point on this one. So after we take a derivative, we'll plug in that point. But I don't want to do the alternate form. I want to do the short form. But there's no short form yet anyway for quotients. So what do I need to do first on this? How do I fix that? What's my algebra fix?
You split it up so that you can run this 6x cubed over x minus 8x over x plus 3 over x.
Oh, I like it. That's being extra. I don't know that most people would show that step, but yes, that's definitely what we do. So 6x squared minus 8 plus, Graham, I know there's nothing wrong with 3 over x, but if I want to take a derivative, I don't really like it to look like that. So what's a better way to write that?
X is the negative 1.
That looks better. Let's see. Now I'm ready to take a derivative. So, Sophia, start us off. What's the derivative of 6x squared? 12x. Also, make sure you label what you're doing. Some of you had this issue on the test, and I tried to call it out when I saw it. It becomes more and more of an issue as we go forward. Like you can't just work all the way down the page and not tell me what those things are. So make sure you're saying f of x equals, and then f prime equals once we've started to take our derivative. So yeah, that was 12x. Maddie, the derivative of minus 8? 0. So again, you can write it if you kind of want to emphasize that the derivative is 0, but you don't have to write it. And then Evan, the derivative of 3x to the negative 1?
Is it negative 3x to the negative 2?
Yes, it is. And then, why are we not done with this problem? Yeah, we've got to... And again, let's label what we're doing. So we want f prime at 1/3. So 12 times 1/3 minus 3 times 1/3 to the negative 2. This is a safe stop. So on a free response question, you should definitely leave it like that. And don't mess with it. On multiple choice, though, it's going to be cleaned up. So let's do a little bit of algebra here. Let's see, 1/3 to the negative 2. So negative flips it, 2 squares it. What did I write? What did I do wrong here? There we go. And then 12 times 1/3 would be 4. And 4 minus 27 is negative 23. And so any of those answers, once you plug things in, you can't just leave it without plugging it in, but once you plug in, you're good. Again, multiple choice is probably going to clean it up, so make sure you know how to get to that final answer. Number 3, find the value of x at which the graph has a horizontal tangent line. Horizontal tangent line. How about show me with your arm, what does a horizontal tangent line look like? Ryder going to 2 arms. What's the slope of this line? 0. So I want to know where the slope equals 0. What's the calculus word for slope? Derivative. So I want to find where the derivative equals 0. Okay, this is a little bit similar to that last one. 5 minus 4x to the negative 1 minus 2x to the negative 2. Oh, let's just keep pulling popsicle sticks today. Ryder, Zach, and Emma. Ryder, the derivative of 5 is? 0. Zach, the derivative of negative 4x to the negative 1? Yes, it would. And Emma, the derivative of negative 2x to the negative 2?
Positive 4x to the power of negative 3.
Okay. Okay, but now we need to find where that's equal to 0. I don't like negative exponents. I mean, I needed them to take a derivative, but now that I'm back to doing algebra, I think I'm going to flip them back over. Whoops, that wouldn't be negative anymore. That's the whole point of flipping it. Any thoughts on what we do to solve this thing?
Is there a reason why on this problem we put the negative exponents back on the bottom but we didn't for the last problem?
Because, so, it's a good question. Why do we left it up here, because we were done with it, so we're done, like leave it alone. I moved them down, I moved them back here because I'm trying to solve where y prime equals 0. And that's going to be easier for me to deal with them down here than it is to deal with negative exponents. Speaking of dealing with them, any idea what we could do to figure this problem out, like algebraically?
Factor out 4x or 4 over x squared.
Let's try that. So definitely 1 for that first one. What does the second spot become? 1 over x. Okay. Okay, this will work. 4 over x squared, that's not going to be 0, because if I plug in 0, I can't do that. So it would be nice then, or the only way this is going to work, is if 1 plus 1 over x equals 0. And maybe you could look at that and figure out what it is. Maybe you'd want to show some steps. But x is going to need to be negative 1. Let's back up and make sure we answered the question here. Find the values of x. And we did. So yeah, we're good. Number 4. Consider the curve given by, at what value of x is the slope of the tangent line of the curve equal to 2? Ryan, talk big picture here. What am I going to do to answer this question?
Find the derivative.
Okay, and we'll let that go. That's not wrong. After we find the derivative, what are we going to do? So that slope of the tangent line, that's find the derivative part. What will we do after we find the derivative? Good, set it equal to 2. So y prime equals 2. Okay, so now I need to find that derivative. Looks like I got 4 derivatives to take. All right, Selah, start us off. What's the derivative of x to the 4th over 3?
4 over 3x to the 3rd.
Good. Tristan, the derivative of negative 3 halves x to the 6th? Minus 9x to the 5. You got the hardest one. Barrett, the derivative of 2x? And then Lexi, 0. And I am not looking forward to solving this, but it says set it equal to 2. Oh, they did us a bit of a favor here. Like a big favor here. Because what am I going to do first? Subtract the 2. And then I can factor out at least an x cubed. 4/3 minus 9x squared. So let's set both of those pieces equal to 0. X cubed equals 0. And 4/3 minus 9x squared equals 0. So x equals 0 is one answer. This answer is going to be kind of ugly, but let's see, 9x squared equals 4/3. So x squared equals 4 over 27. And then I square root both sides. Don't forget the plus or minus. And that could simplify, but we don't care about simplifying in calculus. We're good with safe stops, so we're fine with that answer. Right? right? Previous to this year, your math teachers would take off some points for that because you could clean that up. But we don't care about cleaning it up. We're good with that answer. Number 5. This is different. This is new. Write an equation of the tangent line to this graph when x is 3. Do you remember what do you remember about forms of lines? Like what types of formats do lines look like? It's too vague of a question. Do you know what I'm asking? Because most people revert to mx plus b, but we don't use that very often in calculus. It's not wrong, but we prefer the point slope form. Y minus y1 equals m times x minus x1. We like it because all we need is a point and a slope. So we're going to write that form of the line. We need a point and a slope. This problem should get like 5 stars because we're going to ask this all year long to write the equation of a tangent line. So this method we're going to use over and over and over again. Braden?
How do you know you need to do that?
So you don't have to use point slope. Point slope is just the easiest because getting the slope's easy, but finding the y-intercept, like I don't want to mess with that. I'd rather just have a point to use. So you can use y equals mx plus b, but it takes more work. So we're almost always going to use point slope because it's easier. So I need a point and a slope. Alright, well, x is 3. There's my x coordinate. How am I going to find my y coordinate? Algebra 1 students. What do I do if I have x and I want to find y? Plug it in. So no calculus yet. Just plug in 3. 2 times 3 squared minus 4 times 3 plus 5. Really should have given us more room. Oh, this probably should have been a printer error. Oh well. Let's see. 2 times 9 is 18. Minus 12 plus 5. 6 plus 5 is 11. Okay, and now I am going to flip over and use the rest of this space on this page. And I'm just rewriting some of this. 2x squared minus 4x plus 5. And x equals 3. Okay, so kind of starting over here. I found the point already. So the point, now I know 3 will go in for x1. 11 will go in for y1. But now I need the slope. So 2 words, the entire first semester, you got to link these 2 words in your brain. When it asks for slope, what's the calculus word that goes with that? Derivative. So I need to find the derivative. And I don't know if you've seen this notation before, but a bar just means at x equals 3. Or evaluate at x equals 3. So I need to take a derivative and evaluate at 3. Maybe a better way to write it would have just been g prime at 3. So I need to find the slope at 3. And then whatever the slope at 3 is, that will go in for m. So g prime 4x minus 4 Common mistake on the horizon here. So some students, they get in their head that slope is derivative. Yes, that's good. But then they'll plug this in for m. And I get what they're doing because this is the slope, but this is the slope at any particular x. I need the slope at 3. So I need to plug in 3 to figure out what my slope is. My slope at 3. Let's see, 12 minus 4 is 8. So now I've got my point, I've got my slope. I can plug into the point slope form of the line. Y minus 11 equals 8 times x minus 3. Point slope form. Again, if you want to move things around and get it into y equals mx plus b, fine, but you don't need to do that. Like, leave it alone. And if you remember that it's called point slope form, the reason it's called point slope form is because you need a point and a slope. Why don't you try number 6? Enough of me talking. You do some work. Number 7. A polynomial has a relative extremum. What's up, Laura?
Can you keep it in like 4.5 rather than 18 over 4? Or would
Mhm.
you rather us keep it in fractions?
As long as it's mathematically equivalent, your answer can be anything, as long as it's mathematically equivalent. So if you had left it, in fact, I hesitate to say this because someone's going to do it and I'm going to have to figure it out, but you don't have to evaluate any of that. You could have left this as negative 4.5 times 16 to the negative 5/4. Like, if you wanted to use all of that as your slope, you could, because that's the same thing as negative 9 over 64. So it looks terrible, but it's acceptable because it's the right answer. Like, you don't have to evaluate fractions, decimals, square roots. You can just leave them as they are. Now, as you saw, roughly half the test is multiple choice. If this was a multiple choice question, the answer is going to have this slope, not this slope, even though those are the same thing. So, for your response, by all means, leave it. Leave the junky answers. It's okay. I'm glad you asked that. Number 7. Oh, there's a new word. Relative extremum. Relative extremum. Do you know what that's even talking about? Forget how to find it. Do you know what a relative extremum is? That's a almost technically perfect definition. I'm going to go a lot less technical and just say the top of a hill or the bottom of a valley. Top of a hill or the bottom of a valley. The extremum is the top or bottom part. Relative means there could be other hills or valleys and other mountaintops and valleys, but relative just means on an interval, relative to its neighbors, he's at the top or the bottom. So the top of a hill or the bottom of a valley. So there's the top of a hill and there's the bottom of a valley. If I drew the tangent line at those two spots, what would their tangent line look like? Yeah, their slope would be 0. So relative extremum, y prime equals 0. Because the top of a hill is a flat spot, at least the derivative is 0, and same thing for the bottom of a valley. So that's more vocabulary that leads to derivatives. So yeah, today is vocabulary that leads to derivatives. tangent lines, equation of tangent lines, slope of tangent lines, slope at a point, all means take a derivative. Oh, let's pick on 3 more people. Maybe we'll get through everybody. Braden, what's the derivative of 4x cubed? I did. How did you get 2, you got 2 popsicle sticks in there. Put one of those aside. And they're both in my handwriting, so we can't accuse someone of trying to sabotage your... Oh, I know what it was. You changed classes. When you changed, I made a popsicle stick. And then when I pulled your popsicle stick in 4th period, I put it in 2nd periods. And there's my excuse. Helen, back to this problem. What's the derivative of 4x cubed?
12x squared.
12x squared. Caden, the derivative of 2x squared.
4x.
And Will, the derivative of 1, 0. And we want to know where this is 0. So a little algebra here. Factor out a 4x. Oh, let's just to see if we can get through everybody. We're going to get close. Marie, if 4x equals 0, what does that lead to for an answer? 0. But some people mess that one up. Like they can get the 3x plus 1, but not the...
It sounded like a trick question.
Yeah, well, it is a trick question for some people because they don't know what to do with the 4x thing. And the 3x plus 1 is hopefully easier. Now that I said that, we'll put Daniel on the spot. Negative 1/3. So at 0 and at negative 1/3, we don't know if it's the top of a hill or the bottom of a valley yet. That's for later, but we've at least located where they might be. Okay, not much time left, but these are quick questions. What value of x satisfy f prime equals 0? Well, this matches pretty close to what we just did. Alec, put you on the spot. I've not done a question quite like this. Looking at that graph, where is the derivative 0? What's another word for derivative?
Slope.
Yep, I think so. So at x equals 0. Trevor, give me another spot where we think the slope is 0. Well, both. Yes. X equals n and x equals p. It looks like there's 3 spots that have a slope of 0. On what intervals is slope less than 0? Slope is less than 0. If slope is less than 0, what's the graph doing? Yeah, decreasing, going down, but decreasing would be a better, fancier way to say that. So I would say it decreases from 0 to n. Decreases from 0 to n. That's not a point, right? That's an interval. Slope is less than 0 from 0 to n. Anywhere else the slope is negative? P to infinity. Last one. Where is the slope positive? Negative infinity to 0. And then n to p. So nothing new today, just using these words in different ways. Slope is derivative, derivative is slope. Slope is derivative, derivative is slope. So today's assignment is worksheet number 3.
What? Yeah.
Read carefully. And we got through everybody, so. Got through everybody and took roll at the same time.